I'm Surjit. I'm a cloud data engineer at Google. I work with the professional service organizations at Google. I help customers build their data solutions with Google Cloud. This is going to be the agenda today. I'll touch base upon two of the Google services I'm going to use while doing this CI/CD. Then we talk about the difference between Flex and Classic templates, and we'll do a live demo, and hopefully that goes well. So two services that I'm using in this is cloud source repositories. So it's easier for me to set up cloud source repo. That's why I'm using that. Otherwise, there's alternatives. You can use any other version control to manage your Dataflow Beam code, GitLab, GitHub. And for building the packages for the Flex template and putting into the artifact registry, I'll be using Cloud Build. But alternative, you can use Jenkins as well, or GitLab pipelines also. I've seen some customers use that. So Dataflow templates, it's just a way to package your Beam code. So Dataflow is built on top of open source Beam. So it helps you package your Dataflow code. And there are two types of templates that it allows, Flex template and Classic templates. So with Flex, it lets you build a Docker image with all your dependencies and with the spec file in cloud storage. And when Dataflow launches, it pulls that Docker image and builds your Dataflow pipeline. While Classic is just a JSON serialized version of a graph. The other major difference between the two is Flex allows you to build graphs dynamically, but Classic templates is a static graph. So it's something like if you want to run a for loop of reading multiple tables for the same pipeline, you can do it on a Flex, but you cannot do it on a Classic template. So high level, this is what we're going to do with the demo. We'll push our code to a cloud source repo, which will trigger a cloud build pipeline to build that Flex template. And it's going to do two things. Number one, push the artifact to the artifacts registry. That's a Docker image. And it's also going to put a spec file that's just a pointer to our Dataflow image to the cloud storage bucket. And then we're going to launch it via Cloud Dataflow gcloud command, basically. And I'm going to show you other patterns that can use to deploy this template. And once you deploy it, the only thing that you need to provide to a Cloud Dataflow command, gcloud command, is the template spec file, which has all the information about your parameters and other things that you have baked in. And when Dataflow launches, it's going to pull that artifact registry image, install it on all the workers, and start doing the job. So I'll change my screen to the demo that I have built here. So I have created this code, which is just GCS to JDBC transformation. So it reads data from GCS, writes data to JDBC. I've added a code from pulling in the secrets from the secret manager to connect to a JDBC. And I'm using this Python argparse to extract all my parameters. With Classic, we would have to use value providers for this, but using Flex, it makes it easier so we can pass these parameters on the fly. So I could just pass my secret ID, and in the code, I could define my Flex to pull this from the secrets. And within the JDBC, I've defined, the basic map operation, reading from a GCS, writing to JDBC, that's a PostgreSQL. The two other things that we need to bake in for this one, since I'm using JDBC Python, we need an Xlang IO, which is developed in Java, but we're going to use it in Python. So I'm specifying the jar expansion service that we're going to pass. So we're going to download it from internet, pass it during a build process. So we're just telling the IO where the expansion service is so they can pull it, and also the JDBC driver that we need for our connections. I'm using Postgres. I think by default, JDBC IO has this version of the Postgres driver, but it helps if you want to read from Terat or other MySQL databases. So that's how you can do it. Docker file. So to start with the Docker file, we pull the base image, the version that we're playing with. We have subsequent base images with that. I'm building this in Python 3.9, so I pulled this base image. And the first step is to set your working directory. All our dependencies, basically all our code, has to go into you can put it into a template file. That's where our data flow reads from. And I'm also creating a jar directory. I'm telling my Docker to create a jar directory where all my jars will live in, which I'm going to download. The next portion is where I'm downloading the expansion jar and my Postgres jar from Maven repository and putting that into the Docker image as well. Here I'm specifying my main file that contains all my code, and I'm also installing all the pip dependencies that I have. Since we're running Java expansion service, we also need a JDK so that our code could run. on the system when the expansion service launches. So that's why we are installing Java as well. And finally, copying my Python file as well. So this piece here is where, we are trying to segregating a build or deploy process. If we don't specify this, and in the code, how we specify a Java extension service, what Dataflow will do, it will try to pull it directly from the internet. But generally in the production environment, our Dataflow pipeline does not have internet access. So we tell our Dataflow code, our Beam code, to use the pre-downloaded jar rather than trying to download it from an internet, repository. And in the Docker file as well, if you don't have direct access to pip repository, if you have any other kind of artifact which you're using to manage your package, like JFrog or anything, you can define those commands to pull it on this one, and this will help you, to install your dependency in the file. Since I'm using Cloud Build, this is a basic Cloud Build example that I'm using. So nothing fancy here. The Docker file that I've defined, I'm building that image and I'm pushing into the artifact registry. Already have artifact registry configured, so that's where it's going to push my image to. And finally, I'm creating that spec file. So I'm passing my image path and creating that spec file. So it goes to a GCS bucket. That's where I'm going to read it from. It also has metadata, so when my pipeline runs, it makes sure my parameters are proper. It does that validation checks. That's what it's going to do. Before we run into this, I also want to just showcase how I've configured my triggers for my Cloud Build. So I've connected my repository that we just saw to the Cloud Build that I've created, and I've configured this to run every time there is a new tag. So every time I push my code to a branch, it's not going to trigger. But as soon as I create a release tag, it's going to start triggering. So you can specifically define any kind of tag that you want, or it could also be, you can specify a regis pattern as well. So if you want tag -prod, then you can specify over here. So every time you push a tag which has a prod in it, it's going to start deploying. For the demo, it's going to just start with any name of your tag, and it's going to start building your pipeline here. So I'll stop this and I'll try to run this one then. Just to create a tag. So once this is done, our build should have started, which is gonna do the 3 steps that we defined. It's gonna first pull, build the image, then push the image to the artifact repo, and finally, create that spec file. It's gonna take 3 to 4 minutes to complete this. Cool, I can probably just show the run command of this one. So I do have a pre-built package that's already there on my artifact registry, which is lying. So once you're through with it, once you have your template build, I have not baked in unit tests, so that's where you can bake in unit tests as well. Cloud Build does not have a UI interface for your runs, but if you use service like GitLab pipelines, it has more UI interface, or you can also add in a man-in-the-middle approval kind of thing before you go to prod. So once you have everything set up, that's where, in a gcloud command, you pass your template spec file path. For the worker image, you pass the image and all the other parameters that's being used by your code. Also the JDBC username and the secrets that eventually I'm going to try to pull it from the GCP secret manager, and also the expansion path and class path, which we have included in a Docker file, and make sure it's available. So I'll just run this. That should launch our Dataflow template. Oops. Variables. Okay, cool. Yeah. So once it's going to start, the VM launcher image is going to pull all your packages from the jar. It shows like it's going to pull the JVM image as well. Once it loads, probably I could show where it shows that expansion service image it's trying to pull. But yeah, this is how you can use the Dataflow CI/CD to deploy your Flex templates. Going back to the slides. So that was one pattern. I used gcloud, but in your environment, right, you can use Cloud Composer, Airflow, or Cloud Functions, Cloud workflows as well. And I've seen customers using Terraform as well. not for the batch pipelines, but for the streaming pipelines, which they know like they don't have to redeploy again and again. So these are patterns that you can use to deploy a Dataflow template. So I've included some additional links for how you can build this template. There's also a link for the Google provided templates. It just list off a lot of code that Google already built to use Beam. You can use that, and a good blog by Sergey on why you should use Flex template over classic templates. So yeah, if there's any question, you can connect me with me on LinkedIn. Thank you.